Thank you, Greg.
Thank you so much.
Okay.
Patty.
Do you want to see the fossil lab at all, or just go straight to the
If we can, sure. We'd love to
Do
see
you
a
mind
little
if
bit.
we come film in here for a second? Sure. Yeah.
Everything looking good on camera. Try to get these a little bit.
So this is where we prepare all our fossils after they're excavated. They come into the lab and we clean them, we stabilize them, we repair them if they're broken, and make sure that they're ready for research or display in our museum. This is Judith. Hello. They're working on repairing a bison skull, an ancient giant bison. And this is one that actually was excavated 100 years ago and has been in our collections, and we're bringing it back into the lab for a little TLC because it needs a little stabilization because we're preparing for a museum renovation that's going to involve moving our collections, so we want to make sure all our fossils are nice and robust and up to the journey. Very cool. This is Zed. He is a mammoth. He's about 40,000 years old. And he was discovered when the art museum next door to us needed an underground parking garage. And they ended up finding 16 more old tar pit deposits that had never been discovered before. And so that's been the focus of a lot of our excavation in the last 15 years or so, is preparing, excavating out those fossils. And we've learned a lot about sort of the early record of Rancho La Brea from that project, which is cool. But he's one of our most spectacular finds. We actually found most of his skeleton, which is unusual and very exciting. He's kind of lying on his head here. These are his upper teeth. So the elephants and mammoths have one tooth per jaw, so these are his two top teeth. And then his tusks actually would have come out down here, and they're on display on the museum floor right now.
And by looking at the fossil, you get a little bit deeper.
Yeah, so Zed, a lot of research has been done on Zed. There was a team actually that they drilled out a piece of his tusk, and they were able to analyze the chemicals in layers of the tusk and learn about his life. One thing that you can do when you analyze layers of bone or layers of tusk is you can look at things like seasonality. So mammoths are pretty closely related to elephants, and we think that they shared a lot of behavioral characteristics. And so elephants, the males go through this period called lust every year, where it's sort of hormonally induced leading up to the mating season. They fight with each other and they kind of stop eating, and you can actually see that signature in the bones of the tusks, because if you stop eating, your bones basically stop growing. So just like with tree rings, right? In the winter, they kind of stop growing, so that's how you can count these tree rings and know how many years old a tree is. You can do the same thing with bones a lot of the time. So they found, they discovered that one year, Zed went into must, and then he never really recovered, never really came out. So they had this hypothesis that maybe he died as a result of some sort of soft tissue injury that he sustained while fighting with another male during the mating season. Just a hypothesis, but it's a unique opportunity to look 40,000 years back in time and learn something specific about the life of a specific animal that we have right here. It's amazing.
Very amazing. Yeah, definitely.
This is a direwolf, real direwolf, not a pretend direwolf, but a real direwolf. Although, like most of our skeletons, it's a composite of many individuals, because
We shouldn't touch, right?
you can touch it gently. Yeah. This is our most common animal. We have about 4,000 direwolves that we've discovered. But in the deposits, all the bones get jumbled up, so we don't know if all these bones go together. And in fact, I can tell you this is sort of the wrong size relative to these. So it's very likely that this is many different individuals, and actually the bones in this one skeleton could be like 30,000 years different in age, right? That all put together in that skeleton. Because that's just that's not the way our museum works. This is Stephanie, our lab manager here.
Hi.
That'd be great.
Thank you.
This is Bessy.
Hi.
She's with a podcast called Searching for Goodness. Looking for kind of unity and shared values in people and, learning all about these things. So the idea of your podcast, so we've been talking about climate change and science and Antarctica and all kinds of different things. And Stephanie is doing something that's a really cool aspect of our site, which is, we're really known for like these big animals like that, like mammoths and direwolves and saber-toothed cats, but we actually have hundreds of species of plants and animals that are represented by very small fossils. And so, but we can only learn about them. We have to first process the sediment to get all the asphalt out, and then go through it under microscopes like this to pull out those tiny little fossils, and then we're finding bones of lizards and frogs and songbirds and also bits of insects and
Leaves and seed pods.
planets, shells. So it gives us a really high resolution understanding of the ecosystem. And we can learn a lot more about what the environment was like right here and how it changed at different, through different climatic periods, and also how those changes might be related to the presence or absence of large animals, and also the presence or absence of humans once you get into the ecosystem. So it's a lot of
Very
really
interesting
important
job.
work.
All the detail work.
Yeah, exactly. Thank you.
Thank you. All right, and tell about all this stuff.
So this is some of our fossil collection. These are more bison here, so just like the ones that are being prepared in the lab. So there were, at the end of the Ice Age, a lot of the larger animals went extinct. So people, a lot of times, I get the question of why was everything bigger in the Ice Age? And that's not really the question. Like, we had big animals, big mammals specifically on this planet for like 50 million years. And then very recently, just at the end of the Ice Age, most of the big animals went extinct, leaving the small ones behind. So it's not that things were bigger and they evolved to get smaller, it's we just lost the bigger ones. And so
Almost like a downside.
So, but exactly, it's called, sometimes it's called like trophic downgrading, but yeah, it's like a downsizing. So we lost the larger bison, but we still have small bison.
And the birds too. They
The
had,
birds
like,
too,
those
we
big
lost the bigger
birds
bird,
and
yeah,
the
so there
small
were,
ones.
pterotarans were our largest bird we find here. They're kind of like condors, but with a 12-foot wingspan. Now condors are the biggest bird. You have camels in Turkey?
Yes, I mean, not that common as people think. Not that
We have camels here. This is the humerus, the upper arm bone of a camel, a big camel. So a lot of people don't know that. They're very surprised to learn that we have camels here. Camels actually evolved in North America.
Really?
Yeah. And then maybe 15 million years ago, they crossed a land bridge into Eurasia, and they became the modern camels that you know today. And then 3 million years ago, the Isthmus of Panama formed, and they crossed into South America and became llamas. And then they went extinct here at the end of the Ice Age, but they are true sort of native North American species, just like dogs and horses.
Very interesting to hold like old animals.
The camel bones, there's something just very beautiful about them. They're very kind of sculptural, and they have a nice sort of patina to them, really. these are all the sloths. These are my favorites. So here's some little, these are shin bones, the tibias of the sloths. This one has partial fibula attached. So
Interesting. It would be really ideal to be able to like get this and be able to make it, bring it back.
if anyone was really going to bring back a species, I mean, all the ethical questions aside, I would absolutely choose the giant sloths, because everything else, we also have something that's kind of like it somewhere in the world today, right? We still have elephants, which are like mammoths and mastodons. We still have big cats and big dogs and camels. But like, there is nothing on Earth that is even kind of like an hippopotamus-sized sloth, right? Like, that's an ecotype that's just completely gone. And I would dying to see like what that actually looked and acted like, right?
I would too. And this one, what is this one?
These are more sloth. These are vertebrae, the backbones. These
Sorry,
are ones
my curiosity.
that are specifically pathological, so there's something wrong with them. So they're
Oh, is
evidence
it?
of injury or disease. That's something also that's very special and unique about our collection here, is we have so many individuals that scientists have been able to do studies on what sorts of diseases and injuries animals got, what the rate of injury and disease was, and use that to learn something actually about their behavior. So there have been studies looking at what sorts of injuries saber-toothed cats and dire wolves did, and then using that to infer how they hunted. There are veterinarians that come and do research in our collection on the dire wolves or the horses, to try to see if the types of pathologies they see in their patients, so pet animals, horses and dogs today, were something that were also found in kind of natural populations deep in the past, or if they're related to something that humans are doing to the animal, their diet, or the way that they're being used for locomotion.
Why does it say path to be on it, do you know?
I think path stands for pathology, and I think to be is to be curated.
Oh, I see.
So there's a
It
lot.
sounds like path to be. You gotta be on this path.
Something else we've been able to do, because we have so many fossils, is radiocarbon dating. The preservation is very, very good. So almost all of our fossils, we can get precise radiocarbon dates on them and figure out how old they are. And that way we've been able to figure out when the extinction happened here, which nobody else in the world has really been able to do, because nobody has such a well-dated record, or even a datable record in this sense. So it's been really great. These are some of my favorites. These are the sloth claws. It's a claw of a giant sloth.
Look at that. Very interesting to touch it. I wish I had like one of those permissions to touch it and you see it right in your hand. Like in the show.
And like little baby sloth.
Aw.
Horses and bison. Just all the way down. Horses and bison are third, fourth and fifth most common large animals. The horses are very similar to the horses today. Like, it's pretty hard actually to tell them apart. Sometimes someone will send me a sample of horse to radiocarbon date, and it'll turn out to be like 200 years old, because it was actually from a horse that like the Spanish brought back, as opposed to
From a philosophical point of view, what does it make you feel like that, considering all these living beings from hundreds, thousands of years ago?
It's pretty powerful, like, to touch a bone and realize like this was inside like a living, breathing animal that was right here, right? And we know it was right here because this is where it got stuck and died. It's also really horrible to think about how almost all of the animals we find here, met their death stuck in a tar pit. Not a pleasant way to go, for sure.
Yeah, the sun.
Trapped. You could think of it in a metaphorical way, like we are also trapped by oil that is also leading to our demise, but less, not in the same way, not because we're literally stuck in a tar pit, but still
That's a
causing
nice
problems.
analogy. I've never seen so many bones before.
Nobody else has this many bones.
Well, our audience get the privilege to see these horse-sized bones. Have you always been interested in this, or when does the interest in this kind of thing started?
It's funny. I was always interested in the past, and I, even starting in high school, had the opportunity to work on some archaeological digs, and I always found it really interesting, Egyptology and archaeology. I also, I always loved animals. I grew up, I had pets, I did a lot, hey Gary, did a lot of hiking and camping, and was really interested in wildlife, loved going to the zoo. But, friends of mine, even in college, they would say, well, you like animals and you like dead things, like, why not paleontology? And I always said, no, I think it's just, it just seems to be people, like, describing new species of dinosaurs, and it just seems kind of boring to me. Like, that wasn't what was interesting to me about it. And so it wasn't until, I ended up going into this field of ecology, which I discovered and fell in love with in college, this idea of, like, kind of looking at a whole system, right? Looking at nature as a system and all the different components in the system, and being able to quantify it and sort of predict, like, oh, if you change this, how does that impact this? And then how does that impact this? And then how does that impact this? And this idea that everything's connected in that way. And the ecology professor that I had happened to be a marine ecologist. And so that's how I ended up working in marine biology and working in Antarctica, and I spent years of my life scuba diving and studying invertebrates, crabs and krill and other animals in the ocean. But I still had this sort of tug of the past, right? And I would still go off and work on archaeological digs sometimes. And then on one of those digs, I was introduced to this idea that, oh, you can actually study these system level questions, but in systems that don't exist anymore. And that was when it clicked for me that what I really wanted to do was, I'm in a specialty sort of subdiscipline of paleontology that's called paleoecology, and that's really where my passions kind of all come together.
Thank you for explaining.
So our museum is it's built to so you sort of have this sense of going underground, and the hills, the walls of the museum are all these slopey, grassy hills that the kids love to roll down. Underneath all of those hills, like the entire perimeter of the museum, is fossil storage. So this is just kind of 1.5 hallways of that, but it's really the entire museum with fossils crammed in every nook and cranny, because we just have so much material. This is, these are mammoth teeth. They're surprisingly heavy.
Oh yeah.
Yeah.
That's quite heavy.
So like I said, just one
weight
tooth
with
per jaw.
Oh, wow.
And they have this kind of, so almost like a conveyor belt, like they keep growing because, mammoths and elephants, like they're grazers, right? So largely they're eating grass. Grass has a lot of silica in it that gives it structure, and that's very tough, but also, when you're eating grass, you're eating stuff on the ground, you're getting a lot of grit in your diet.
I'm curious,
and so
do you
you have
think
to keep growing.
they kill and eat these animals?
There are a lot of sites in North America and elsewhere where we have very clear evidence of humans hunting and eating mammoths in particular. There are also sites where we have evidence of humans eating extinct camels and horses. only a couple where there's evidence of butchering of sloths. Some sites where humans were hunting mastodons. So definitely they were a resource for, the first people who came into North America.
Oh, humans like to eat everything.
Mammoths?
Yeah.
No, they're like elephants.
They're like
They
elephants.
look like elephants, look just like elephants, maybe a little bigger. This is the rest of Zed, so the mammoth skull we saw in the lab.
Yes.
This is, we found, like I said, he's an interesting case. He did not get stuck in a tar pit, it looks like most of the rest of our fossils. He actually died and was buried in a stream bed, which is kind of more normal for fossils. That's how fossils usually get preserved, is they die and they get covered pretty rapidly by sediment, usually by a river. And so we actually found most of his body. So these are all his ribs. These down here are his shoulder blades, and you can see there's actually still tar dripping out of them, which is really cool. Got his upper arm bones there, his leg bones. There's his pelvis, a lot of his vertebrae here. So it's, he's a really cool individual to study that we can, get information from that we can't get from a lot of our other animals, because we
You have
can
a lot
actually
of
say
body
all
parts.
these bones go together in one animal.
That's rare, huh?
Yeah.
It's rare.
Rare for us.
What happens usually? They dissolve in time? They dissolve or?
Well, no. So when an animal gets stuck in a tar pit, a couple of things happen. So parts of the animal will probably either decompose or get carried off by scavengers, the parts that are sticking up above the tar. Eventually, some of it will get buried, and so what's sort of stuck in the tar and then gets buried by sediment and more seeping tar will become preserved. But then, because the asphalt, the tar, is actually creating this kind of viscous medium, it's not solid like just sediment. And you have these bubbles coming up from the natural gas deposits that co-occur with the oil. And so it tends to sort of just churn things around a bit. So the skeletons get disarticulated. So it's pretty rare to find articulated bones. That's to say, bones that go with one animal that are all sort of in anatomical order, because everything's been sort of jumbled up and sort of shuffled together in these deposits.